Have you ever wondered how an app like Netflix can handle millions of people all hitting play at the exact same time without crashing? Well, the secret is something called scaling. And really, it all comes down to one huge decision. Do you build one massive, super strong server, or do you build an entire army of smaller ones? Okay, just picture this for a second. You've built an amazing app, it goes viral overnight. I mean, everyone is downloading it. But you've got a massive problem. Your server just can't keep up. It's slow, it's crashing, and all those new users are getting really frustrated. Now, this is a fantastic problem to have, right? But it's a problem you have to solve, and you have to solve it fast.
And to figure out the solution, we're not going to start by looking at complicated code or server architecture. Nope. We're going to talk about something way simpler and, let's be honest, way more delicious. A pizza shop. Trust me, this analogy is going to make everything click.
All right, so you own a little pizza shop, and you have this one chef who is just a genius, makes the best pizza in the entire city. Word gets out and boom, you're a hit. Suddenly, you have a line of hungry people wrapping all the way around the block.
Your success has created a huge bottleneck. The orders are just piling up, customers are getting antsy, and your one amazing chef, as good as they are, is totally swamped. The whole system, your pizza shop, just can't handle all this demand. This is the exact same thing that's happening to your crashing server.
So let's break this down. What's your first move here? What's your gut instinct to solve this pizza problem? You probably want to make your current setup better, right?
You could, pay your chef a bonus to work faster. You could go out and buy them a massive state-of-the-art oven. You could streamline the whole process from dough to box. Basically, you're pouring all your resources into making your one single chef as powerful and as efficient as humanly possible.
And in the tech world, there's a name for this. It's called vertical scaling. You might also hear it called scaling up. It's just like upgrading your own computer. You're not buying a second laptop, you're just adding more RAM or a faster CPU to the one you've got. You're making one single machine bigger and more powerful. And of course, the opposite is true. If traffic slows down, you can also scale down by removing some of those resources to save a little money.
Now, this approach seems pretty straightforward, right? But it has one giant, glaring vulnerability. Just think about it for a second. What happens if your one and only, super optimized, incredibly expensive chef calls in sick? Yep, your entire shop grinds to a halt. No pizzas, no happy customers, no money. Your business is just down for the day. This critical weakness has a name. It's called a single point of failure. And it's a huge deal, because when your whole system depends on just one thing, if that one thing fails, everything fails.
Okay, so if making one super chef is just too risky, or maybe you've already bought the biggest, baddest oven on the planet and it's still not enough, what's the alternative? Well, instead of one super chef, you go out and hire an army of chefs. 10, 20, maybe 100 regular chefs. They each get their own standard oven, and they're all working at the same time, in parallel, just cranking out those pizzas.
This, my friends, is horizontal scaling, or as you'll often hear it, scaling out. Instead of making one server bigger, you're adding more servers to your system. You're not scaling up, you're scaling out. It's the difference between buying one giant semi-truck versus buying a whole fleet of delivery vans.
But wait, now you've got a new kind of problem. With 100 chefs, how do you decide who gets which pizza order? You can't just have chaos. You need a manager out front, basically acting like a traffic cop, directing orders to chefs who are free and making sure no one person gets totally overwhelmed. In the tech world, that manager is a piece of software called a load balancer. Its entire job is to spread the incoming work evenly across all of your servers.
So which one is actually better? The one super chef or the whole army of chefs? Well, the truth is, neither one is perfect. They both have their own pros and cons, and this is where system design gets really interesting.
This table really cuts right to the heart of it. Just look at that first row, reliability. Vertical scaling has that scary single point of failure, but horizontal scaling, it's resilient. That is a massive advantage. But then, look down at complexity. Horizontal scaling is way more complex because you need that whole load balancer setup we just talked about. See, it's always a trade-off.
Let's just be crystal clear on this point. With vertical scaling, you're putting all of your eggs into one very powerful, very expensive basket. And if that basket drops, it's game over. Everything stops.
And this is the real magic of horizontal scaling. If one of your 100 chefs gets sick and goes home for the day, who cares? You've still got 99 other chefs making pizzas. This system barely even notices. This ability to withstand failure, sometimes called fault tolerance, is exactly why most big, modern applications lean so heavily on scaling out.
So after all that, what are the big players?
You know, the Amazons, the Netflixes, the Facebooks. What do they actually use? Do they go for the one giant super server or the massive server army? Well, the answer, and maybe this isn't so surprising, is they use both. The smartest systems don't just pick one. They build a hybrid, taking the best parts of each approach.
So here's how that actually works. A company like Google will have thousands upon thousands of servers all around the world. That's the horizontal scaling, the scaling out. But each one of those individual servers is also a beast of a machine in its own right. That's the vertical scaling. This hybrid model gives them the absolute best of both worlds. They get the resilience and fault tolerance from having many machines, and they get the raw speed and power for making each of those machines really strong.
When you boil it all down, this entire conversation is about a balancing act. Every single person designing a system is constantly juggling these three things. How much traffic can we handle? How do we survive when things break? And how do we make sure our data is always accurate? The tricky part is, you can almost never have a perfect score in all three at the same time.
And that really brings us to the single most important lesson here. In engineering and system design, there's almost never a single perfect answer that just works for every single problem.
It's always about understanding the trade-offs and then choosing the right balance for what you are trying to build. So the question I want to leave you with is this. If you were building that next viral app, what would you prioritize? Raw speed? Unbeatable uptime? Keeping costs low? Your answer to that question will define your entire scaling strategy.